Hey everyone! So, you've probably used something like ChatGPT or maybe Google Translate and just marveled at how well it understands language. It feels like magic, right? Well, it's not magic. The secret behind it all is a groundbreaking technology called the Transformer model.
And I'm not exaggerating when I say that. This architecture is literally the engine driving almost every major AI breakthrough we're seeing today. It's totally fundamental.
That is the million-dollar question, isn't it? And it's exactly what we're going to unpack right now. We're going to peel back the layers and really see the clever ideas that make these things tick. All right, let's dive in.
Now, to really get why transformers were such a massive deal, we first have to understand what came before them and the huge problem they were built to solve.
Okay, so imagine trying to read a long sentence, but you're only allowed to look at one single word at a time in a strict, linear order. That's basically how the older models like recurrent neural networks or RNNs had to work. They'd process the first word, pass a little bit of memory to the next step, then process the second word, and so on and so on. This created some serious bottlenecks.
And this really lays it all out. On one side, you have the old way. These sequential models were incredibly slow to train because everything had to happen in order. And crucially, by the time they got to the end of a long sentence, that memory from the beginning had faded away. They would literally forget the context from the start. But transformers, they process all the words at the exact same time. This makes them way faster to train, and most importantly, they can see and understand the entire context of the sentence all at once.
But, just processing everything at once only solves the speed problem. How does the model know which of those words are actually important to one another? Well, the answer came from a truly brilliant idea that changed everything.
This is the title of the legendary 2017 paper from Google that introduced the transformer to the world. And the title itself tells you everything you need to know, pointing right to the core idea that makes these models so incredibly powerful. So this right here is the winning formula. You've got parallel processing, the ability to look at all the words at once. And you combine that with attention, a way for the model to weigh the importance of every word against every other word. These two ideas together were an absolute game changer.
Okay, so let's get into the real secret sauce here, the attention mechanism, or to be more specific, self-attention. This is truly the heart and soul of the transformer.
It's such an intuitive way to think about it. For the model to figure out what a word means in context, it basically looks at all the other words in the sentence and asks, okay, which of you are most relevant to me? This example just makes it crystal clear. When we read this, we instantly know that it refers to the cat. Well, self-attention gives the model that exact same superpower. As it's processing the word it, the attention mechanism creates a strong link, a high attention score, back to the word cat. It's basically calculating a weight that shows how related those two words are in this specific sentence. So how does it do this on a technical level? Well, for every single word, the model generates 3 separate vectors: a query, a key, and a value. Think of it like a super efficient library system. The word we're focusing on sends out a query, which is like it's asking a question. All the other words present their keys, which are like the titles on the spines of books, announcing what they're about. The model finds the best match between the query and the keys, and then those relevant words provide their value, which is the actual information, the meaning inside the book. It's just a really elegant way to calculate context at a massive scale.
But here's where it gets even cooler. The model doesn't just do this once. It runs this attention process many times in parallel, using something called multi-head attention. This is so clever, because language is complicated, right? So one attention head might get really good at tracking pronouns and what they refer to. Another head might focus on grammatical structure. Maybe a third tracks cause and effect. It's like having a whole team of specialists analyzing the sentence, each from a different angle, to build a much richer, deeper understanding.
All right, so we've got this incredibly powerful self-attention mechanism. Now, let's zoom out a bit and see how it fits into the overall architecture of the model.
A standard transformer is usually built in 2 main parts. First, you've got the encoder. Its entire job is to read the input text and, using all that self-attention we just talked about, create a really rich mathematical representation of what it means. Then you have the decoder. Its job is to take that bundle of meaning from the encoder and start generating an output, word by word, like a translation or an answer. And what's so fascinating is that you can build world-class AI models using just one of these halves. For example, models like BERT, you've probably heard of it, are basically just the encoder part. They are designed for one thing: deep understanding. so they're great for things like search or sentiment analysis. And then on the flip side, you have models like the GPT family. The G in GPT stands for generative, which are primarily just the decoder part, and they're absolute masters of generating human-like text.
So, now that we have all the building blocks, let's just take a moment to appreciate why this architecture completely turned the world of AI on its head. It really boils down to three things. First, they're fast. That parallel processing means we can train them on just insane amounts of data. Second, they are incredibly scalable. The bigger you build them and the more data you feed them, they just keep getting smarter. And finally, they're just plain powerful. They can capture those tricky, long-range connections in text that older models could only dream of.
And that powerful combination led to a complete explosion in what we could do with AI. The high-quality machine translation we use every day, the sophisticated chatbots we talk to, even AI that can write computer code for us, all of it is built on the back of the Transformer architecture.
All right, I know we've covered a ton of ground, so let's just do a really quick, simple recap to put all the pieces together.
So first, they look at the whole sentence at once. Second, they use that clever self-attention trick to figure out how all the words relate to each other to build a deep understanding of context. Third, that information gets processed through stacks of encoder and decoder layers. And finally, based on all that understanding, they generate a brand new intelligent output.
And really, if you remember nothing else from this, remember this simple formula. The magic of transformers comes from combining the brilliant concept of attention with the raw speed of parallel processing. That's the whole game.
And there you have it. From the old problems of sequential processing to the breakthrough of self-attention and the powerful encoder-decoder architecture, you now have a really solid grasp of the engine that's driving modern AI.
You know, this whole revolution was kicked off by finding a new way to pay attention to data.